Good morning, students. So far we discussed all the basic concept in parabola and also all the basic concepts in ellipse. Today we are going to discuss hyperbola. From the basic definition of conic, see, we already discussed Fp by Pm equal to E. This is the basic definition of conic. Here F is called focus and L is the directrix. Based on eccentricity, we are splitting three ways. We are splitting in three ways. The number one, E equal to 1, then it is to be a parabola. Number 2, E less than 1, then it is to be an ellipse. So far we completed these two topics. Now today we are going to discuss about if E greater than 1, then the conic is to be hyperbola. So from the basic definition of conic, we are discussing about already two topics. One, parabola. Number 2, ellipse. Today we are going to discuss about hyperbola. See, a hyperbola is a conic with the eccentricity E greater than 1. So we are going to discuss the hyperbola. The first topic is standard equation of the hyperbola. So from the basic definition, we are classified the conic as three ways. Number 1, parabola. Number 2, ellipse. Number 3, hyperbola. So a hyperbola is a conic with the eccentricity E greater than 1. That is the basic definition. Now standard equation. Standard equation of the hyperbola. This is the heading. Today we are going to discuss standard equation of the hyperbola. Already we discussed standard equation of an ellipse. You refer that explanation. Now we have only one small difference. For an ellipse E less than 1, here for a hyperbola E greater than 1. That is the only one difference. All other explanations are same only. See the first one. Let F be the focus. Let F be the focus. L is the directrix. L is the directrix. All these explanations are similar to the standard equation of an ellipse. Now E greater than 1 is the eccentricity. Here only small change. You can refer your standard equation of an ellipse. Here E less than 1. There in your standard equation of ellipse, E less than 1. Here E greater than 1. All other explanations are same. Let F be the focus. L is the directrix. E greater than 1 is the eccentricity of a hyperbola. Now we have to draw this explanation here. See the three explanation. F be the focus. L is the directrix. E greater than 1 is the eccentricity of a hyperbola. Now see the diagram. Already we discussed all the concepts. Today we have a small difference. See this. Let F be the focus. L is the directrix. See, L is the directrix. Here F is the focus. See here. First two lines. E greater than 1 we are going to use when we are working out the problems. Now, see the explanation. Next explanation. Draw Fz perpendicular to the directrix L. See this word? Draw Fz perpendicular to the directrix L. We already worked out the directrix L. F is the focus, that is a fixed point. Let F be the focus, it is a fixed point. Now we are going to draw Fz. Therefore, from this, draw a line perpendicular to draw Fz. Perpendicular to the directrix L. Draw Fz perpendicular to the directrix L. Now, the next explanation. Let A and A dash, let A and A dash be any 2 points, on Fz, which divides Fz internally and externally, in the ratio E is to 1. You can refer the standard equation of an ellipse, same explanation only. So draw Fz perpendicular to the directrix L. After that, let A and A dash be any 2 points on Fz which divides Fz internally and externally in the ratio E is to 1. See this explanation. Let A, here I can take A, which divides Fz internally. Now another one point, take here A dash. A and A dash which divides the line Fz, this is internally, another one is externally. So A divides internally, A dash divides externally in the ratio E is to 1. The same explanation you can refer in your standard equation of the ellipse also. Now let A dash equal to 2A. So we are having some distance between A and A dash. Let us consider the distance is 2A. So A dash equal to 2A. We are considering it is a constant 2A. C is the midpoint. C is the midpoint of A dash. So A dash equal to 2A, it is a constant distance. In between we are considering a point C. Consider C. C is the midpoint of A dash. Therefore we can say CA equal to CA dash equal to A. That must be equidistant. CA equal to CA dash equal to A. Total distance A dash equal to 2A. Once again, so far, listen all the explanation. Let F be the focus, L is the directrix, E greater than 1 is the eccentricity. When we are working out the problems, we are able to see that E greater than 1. Now we are going to work out the theoretical concept. After that, draw Fz perpendicular to the directrix L. Let A and A dash be any 2 points on Fz which divides internally and externally in the ratio E is to 1. Let us consider the distance A dash equal to 2A. C is the midpoint of A dash. Therefore, CA equal to CA dash equal to small a. So up to this, we are clarifying all the things, all the explanations. Now listen. Now consider this CF as the positive direction of x-axis. Consider CF as the positive direction of x-axis. Positive direction of x-axis. See this sentence. Consider CF, this CF as the positive direction of x-axis. So that I am considering this is x-axis. After that, CY perpendicular to CF. CY perpendicular to CF as y-axis. As y-axis. Now CF. Now we are going to draw another line CY which is perpendicular to CF as y-axis. Therefore automatically C has to be the origin. Therefore C is the origin 0, 0, because the meeting place of point of intersection of x-axis and y-axis, nothing but the origin. See this explanation. Consider CF as the positive direction of x-axis, CY perpendicular to CF. This is CY perpendicular to CF as y-axis. Therefore, it is the point of intersection of the x-axis and y-axis. Therefore, it is nothing but the origin 0, 0. So now C is considered to be origin 0, 0. The same explanation you can refer in your ellipse also. C is the 0, 0 origin. Now listen. See this concept now. A divides FZ internally in the ratio. Already we explained this one. See this one. A divides FZ internally in the ratio E is to 1. So now A divides this distance FZ internally in the ratio E is to 1. So I can write like this: FA divided ratio AZ equal to E is to 1. This ratio can be considered as the division FA divided by AZ equal to E by 1. So I can write FA equal to, cross multiplying this one, E times AZ. FA equal to E times AZ. Say this is equation number 1. See the explanation. A divides FZ internally in the ratio E is to 1. Therefore, I can write like this: FA ratio AZ equal to E is to 1. So, ratio is nothing but division. So, FA divided by AZ equal to E by 1. Cross multiplying, you can get FA equal to E times AZ. We are able to derive equation number 1. Just I can take this result here. FA equal to E times AZ. Say this is equation number 1. Now, in the same way, just instead of this A, I am taking A dash. A dash divides FZ. Instead of this word internally, take the word externally. So here A divides internally, A dash divides externally. So A dash divides FZ externally in the ratio E is to 1. Therefore, once again divide. So A already divides FZ internally in the ratio. Now the same one, FZ, A dash divides FZ. So I can write like this: F A dash ratio A dash Z equal to E ratio 1. So I can write like this: F A dash divided by A dash Z equal to E ratio 1 can be written in the form of E divided by 1. So F A dash equal to E times A dash Z. Say this is equation number 2. Once again, see the second explanation. A dash divides FZ externally in the ratio. Therefore, I can write F A dash ratio A dash Z equal to E ratio 1. So ratio is nothing but division. Then cross multiplying, we can get F A dash equal to E times A dash Z. I am taking this result here. F A dash equal to E times A dash Z. Say this is result number 2. So F A dash E times A dash Z. This is result number 2. So we are getting 2 results. Equation number 1 and 2. See your ellipse explanation, standard equation of ellipse. The same result you are able to obtain. Now I am going to adding 1 and 2. Another time subtracting. So one time adding the equation, another time subtracting the equation, we are able to get some new result. See now, I am going to add 1 and 2. I am going to add a 1 and 2. See the result. Equation, first equation, second equation. Adding means LHS adding with the LHS. FA dash equal to RHS adding with the RHS. E times AZ plus E times A dash Z. See, LHS adding with LHS. FA plus FA dash equal to E times AZ plus E times A dash Z. See, FA plus FA dash equal to, I am taking out E as common, the remaining is AZ plus A dash Z. AZ plus A dash Z. See your explanation. AZ, where it is placed? AZ. See, A is here, Z is here, this portion. Another one, A dash Z. So first portion is AZ, second portion is A dash Z. Instead of these two addition, I can write like this. AZ, A dash Z can be taken as A dash. See your board clearly. This is AZ, A dash Z. So I can add the two portion. Instead of separate addition, I can take A dash instead of this one. See in your LHS side, FA. FA is placed here. This is FA. This portion is FA. So in terms of from the center, I can split this distance. AF or FA is the distance. This distance I can split like this from the center. CF minus CA. I can write like this. Once again see the board. I need this AF or FA. This distance I want. I can write from the center CF minus CA. This is nothing but FA. In the same way, FA dash. See here F. A dash in the other portion. So I can write this FA dash in terms of center means CF plus CA dash. This is important explanation. So see the explanation in your board and take down. Use the fingers properly. You are able to get it. FA means this smaller portion. It can be split in the form of the center means CF is the maximum minus CA. Again C plus. FA dash is the second value. F is here. A dash means here. It is more than the center. So I can write CA dash plus CF. See this one. So now CF, here also one CF. I can get 2 times CF. I can get 2 times CF. See already in your explanation, CA equal to CA dash, both are same value A. So this positive CA, negative CA dash, both are, becomes the value A. Therefore, these two values will be eliminated. CF, again adding with the CF, we can get 2 times CF. See in your RHS, E is already a constant taken out. A dash equal to 2A. We already considered the distance A dash equal to 2A. This A dash equal to 2A. Now see here, 2 will be removed. Therefore, we are getting the result CF equal to AE. See, this is the one of the result we need to working out the standard equation of a hyperbola. The same result in your ellipse also, CF equal to AE. So we are working out then another one result, CF equal to AE. So when we are adding the result 1 and 2, so see adding 1 and 2, we are taking the LHS separately and RHS separately. In your RHS take out E as a common, then work out. This AZ plus A dash Z can be written as A dash. Here we are having two distance FA, FA dash. These two distance must be converted from the center. See, CF, CA, CF, CA dash. All these four data is having the center C, using the letter C. So it can be converted in the form of the center. Then eliminate the positive CA and CA dash because CA equal to CA dash. Both will be same result. Then CF adding with the CF, we can get a 2CF. 2 will be removed. CF equal to AE. It is the one of the result we need to solve the standard equation. Then see the another one. We are adding the two equation 1 and 2. Now we are going to subtract. In the subtraction, FA dash is the greater value. See, F is here, A dash is here. This is the greater value. FA must be less. So that I can write like this, 2 minus 1. Second equation minus first equation. See the second equation in the same way. LHS subtracted with LHS. FA dash. FA dash minus FA equal to E times A dash Z minus E times A Z. See, LHS is subtracted with LHS. FA dash minus FA equal to RHS side. E A dash Z minus EZ. See, F A dash. F is here, A dash means here, F A dash. This is the total distance from this F to A dash. Remove this F A, that means subtract this F A. We can get A dash. Use the finger properly. You can get the ideas very clear way. See, F A dash is initially this is. I want to subtract this F A. Therefore, my finger comes here. This is nothing but A dash. Now take out E as common. A dash Z. See, A dash is here. Z is here. It is more than the center. Therefore, I can write this one in terms of center. C A dash. C A dash. Then plus C Z. See then, A dash is here. A dash is here. Z is here. It is crossed over the center. Therefore, separate addition of these two. C Z, C A dash. So C A dash plus C Z. Then already you are having negative. Already taken out E as a common. Now the remaining A Z. Where is A Z placed? See, this is A Z. Therefore, it can be converted in terms of center means CA minus CS. Sorry, CZ. CA minus CZ. Close this bracket. Once again, see the explanation properly. Use the fingers, then you can get the idea. See here, F A dash minus F A. Then my fingers moving to this. Subtraction means moving from A to this. So now my fingers are placed in A dash. So take this is A dash. Take out E as the common. Then A dash is A dash here. Z is here. Therefore, I can convert A dash Z in terms of two additions. C A dash plus C Z. Then minus A Z. A Z is here. This portion can be expanded in terms of center means CA minus CZ. So CA minus CZ, we can get this one AZ. Now open this bracket. See A dash, already we know the value 2A. So E is already common. Open this bracket. C A dash plus CZ. Then open means minus CA. Minus of minus plus CZ. Then positive CA dash, negative CA will be removed. Already we discussed it must be equal value. CA equal to CA dash. Therefore it must be removed this positive and negative. See the result. LHS you are having 2A. In your RHS, E times, E is already taken out. CZ, again one more CZ. We can get 2 times CZ. 2 will be removed. Therefore, we can get A equal to E times CZ. Therefore, I can write CZ equal to A by E. We are working out one more result. CZ equal to A by E. So these are the first required things to working out the standard equation of a hyperbola. The same one for the ellipse also. So CF wanted, CZ wanted, then already A and A dash must be the equidistance. That means A dash equal to 2A. Already we decided that distance. So CA equal to CA dash equal to small a. These are the needed things first. So working out the result, adding 1 and 2 first time, then 2 minus 1, that is the second result. We are getting CF, another one CZ. So dear student, work out yourself, try yourself, use the fingers, all are the distance only. So adding 1 and 2, subtracting 2 from 1, so then you can get CF, CZ. Now already we are deciding x-axis and y-axis. Now listen, C is the, already thinking about the C is the, considering C is the origin. So 0, 0. Now listen, CZ equal to A by E. That is the distance. We need the point Z, A, F lies on x-axis only. So see, Z, A, F lies on x-axis. Therefore, now the points Z points are, now the points are Z, see A by E, comma 0, and A already we decided A, comma 0, Now the point F AE comma 0. So already we are giving the name F is the focus. Now we are working out F is the focus. Its value is AE comma 0. Then A is A comma 0. The reason is already we decided CA equal to small a. That means it lies on x-axis. Now the point is A comma 0. Z is a point. CZ value is A by E. Just to be worked out, Z is lies on x-axis. Therefore the point A by E comma 0. Now I am taking all this here. A by E comma 0. Just now. This is the point A comma 0. Then F is AE comma 0. So these are the points we need to evaluate the standard equation. See the point F AE comma 0. Now the point A is A comma 0. Z is A by E comma 0. Take down clearly A by E comma 0. These are the important concept we need. So now Z A by E comma 0. Now A comma 0 F A by E comma 0. So that we are already working out all the results. All the results here. See F AE comma 0 A comma 0 Z A by E comma 0. Now let us consider, let P of x comma y be any point. Let P of x comma y be any point on the hyperbola. Let P of x comma y be any point on the hyperbola. So P of x comma y be any point on the hyperbola we are going to take here. See here, already we are taking 3 points. Z A by E comma 0, A comma 0, F A by E, AE comma 0. Now I am taking, see here, P of x comma y be any point on the hyperbola. Now join FP and draw PM perpendicular to L. So join FP. See here, I am going to join FP and PM. See here, PM perpendicular to the directrix L. So these are the two new logics. Let P of x comma y be any point on the hyperbola. Join FP and draw PM perpendicular to the directrix L. See here, FP already worked out AE comma 0. Now considering P of x comma y, because P of x comma y be any moving point, already we worked out in the standard equation of the conics. Now listen, Z is A by E comma 0. Now the point M, this is the M, PM perpendicular. Now M is A by E comma y, because here y value is unknown. This value is y unknown. We can refer here also. It is a perpendicular. Therefore, we can take the y quantity here. A by E comma y. This is the value. Y is unknown. See the logics. M is A by E comma y. P is the point P of x comma y. F is the point AE comma 0, because F lies on the x-axis. Now the basic definition of conics. So now P of x comma y any point on this hyperbola, then join FP and draw PM perpendicular to the directrix L. Directrix L. Now listen. By the basic definition, from the basic definition of conic, what is the basic definition? Already we know FP by PM equal to E. So I can take this one, FP equal to E times PM. So FP by PM equal to E, I can take FP equal to E times PM. See here, what is the meaning of FP? It is nothing but the distance between 2 points. FP means, square root of distance between 2 points, x minus ae the whole squared plus y minus 0 the whole squared. Here, e times. What is the meaning of PM? PM is also the distance between 2 points. Work out x minus a by e. Take this square root of x minus a by e the whole squared plus here y minus y. Y minus y the whole squared. See this one. Fp equal to e times Pm. Fp means distance between 2 points. X minus ae the whole squared plus y minus 0 the whole squared. E is an eccentricity, it is a constant. Here square root of Pm is also the distance between 2 points. Then x minus a by e the whole squared, y minus y, that means whole squared. Now we want to remove the root family, so I can take the squaring both sides. So I can take the squaring this value. So now we can get x minus ae the whole squared, x minus ae the whole squared plus y squared equal to e squared. Then the other value is x minus a by e the whole squared. X minus a by e the whole squared. X minus ae the whole squared plus y squared equal to e squared. Here x minus a by e the whole squared. Now we want to simplify this. We want to simplify this. That means just expand it, we can get the result. See here your LHS x squared minus 2x ae plus a squared e squared plus y squared equal to e squared. Here x minus a by e the whole squared. Expand it. X squared minus 2x a by e plus a squared by e squared. Just listen this concept once again. Here it is in the form of x minus ae the whole squared. So x squared minus 2x ae plus a squared e squared. A minus b the whole squared. Here we can get y squared. In your RHS side, e squared of x minus a by e the whole squared. So x squared minus 2x a by e, then a squared by e squared. Just to open this bracket, we can get the LHS x squared minus 2x ae plus a squared e squared plus here y squared. Just to open this bracket, we can get x squared e squared. Then again minus 2x ae, one e will be removed. Then plus e squared will be removed here. We can get a squared. Just to open this bracket, we can get x squared e squared. Again e squared will be, one e will be removed. We can get 2x ae. Then a squared is the another one. See here 2x ae. Here also 2x ae will be removed. Now what are the remaining things? See here x squared plus a squared e squared plus y squared equal to the other side. We can get x squared e squared, then a squared. See once again, just it is in the form of a minus b the whole squared. Expand it, then we can get this result. Then open this bracket, e squared will be multiplication inside. So we are able to get up to this result the same ditto explanation with the same as in your standard equation of ellipse. Now we are going to change a new small concept will be changed. See this one. See the board clearly and you can get. See here x squared e squared. I can take this x squared to the other side. This y squared also other side. See here. I am already having x squared e squared. Then this x squared will be converted to the other side. Minus x squared. Then this y squared will be already this side. Going to the other side. Take this a squared here. See here. A squared e squared minus a squared. See this carefully. This is the change different from the standard equation of ellipse. So I am taking this x squared other side, y squared also other side, a squared here. It is the only one conversion. See here I am taking x squared common. The remaining is e squared minus 1. Then minus y squared. Here I am taking a squared as the common. The remaining is e squared minus 1. So divide this one. So see this. This is the change when compared with your standard equation. So standard equation of the ellipse. See the only one change there. I am giving the explanation why it needs like that. So I am taking x squared as common. X squared of e squared minus 1 minus y squared a squared of e squared minus 1. Divide that one by a squared of e squared minus 1. So the standard equation must be x squared of e squared minus 1 divided by a squared of e squared minus 1 minus y squared divided by a squared of e squared minus 1 equal to other side same result will be removed. Now this e squared minus 1 will be removed. Therefore x squared by a squared minus y squared divided by a squared of e squared minus 1 equal to 1. When compared with your standard equation of an ellipse, here you are able to see a change. In your ellipse, it must be a squared of 1 minus e squared. The reason is e less than 1 in your standard equation of ellipse. Here e greater than 1. Therefore, a squared of e squared minus 1. You can refer your standard equation. Now I am giving the name here. The same type of name we are giving in your standard equation of an ellipse. Therefore, see here I am giving let b squared equal to a squared of e squared minus 1. So I am giving this name here. Therefore, x squared by a squared minus y squared by b squared equal to 1 is the standard equation of a hyperbola. See your standard equation of ellipse. You are having the plus symbol. Here we are having the negative symbol. So x squared by a squared minus y squared by b squared equal to 1 is the standard equation of a hyperbola. Here we are giving the name b squared equal to a squared of e squared minus 1, and compare with the ellipse, you are able to see here 1 minus e squared. These are the very small changes. Diagrammatically, we are able to see some difference. So dear students, try to work out yourself. See the results. Then compare with your already worked out the standard equation of an ellipse. The same result maximum you are able to see. Just in the last work, we are going to convert like this. Standard equation of the hyperbola is x squared by a squared minus y squared by b squared equal to 1. So try to work out yourself. Compare with the standard equation of ellipse. Tomorrow we are going to discuss the diagrammatic explanation of this hyperbola. Thank you.